Hello, this is James Black, instructor for Montana State University's EMEC 360/361 Measurements and Instrumentation course. I'm here to give you some prep material for our voltage-based temperature measurement lab. Specifically, we are using thermocouples to measure temperature, and we are examining the first order response of those thermocouples. And we're also just becoming more familiar with LabVIEW and lab equipment. The premise of this lab, we're going to take this specimen, I'll say more about that soon, but we take this specimen, we go from room temperature and we insert it into a much higher temperature. The lab handout says 80 to 100 degrees Celsius. I've set this just to 90 degrees Celsius. So this is a refrigerated circulating bath. We have it set to 90, like I said, 90 degrees Celsius. So we're not using the refrigeration part. Because of that, this one's a little bit weird in that it has this switch between having the refrigeration on and the heating on, and that they can kind of even fight each other at times. We don't want that, so we're just putting it down here to the plus 35 to 100 degrees Celsius setting. Then there's no fighting. We'll just, as quickly as possible, get up to 90 degrees Celsius. And that's an important point. When you get in here to lab, if it's not already set up for you, then get the bath set up, flip the switch down, plug it in, obviously, set it to 90, and make sure that it's starting to heat up to get you to that 90 degrees Celsius, so that once you've got all your other equipment set up and you've created your LabVIEW VI, then the bath is going to be ready for you. Now, a little more, one more note first. We also have these newer baths. You may be in one of the groups that uses those. We'll give some more instruction for those. They're very easy to figure out. That's the easy part of this lab. So a little more about the specimen. It is an aluminum rod, and we have 5 thermocouples embedded in it. Well, actually 4 are embedded in it. We have 1, 2, 3, 4. They're embedded at different distances from the end that we're going to insert into the bath. And then we have a 5th thermocouple that just kind of hangs freely out here. Let's talk a little bit more about what we're going to do with these thermocouples. So like I said, there's 5 of them that are coming out. And I have one full set up over here. I'll just show you the exact same equipment here. We had one lab previous to this, our first lab, where we use LabVIEW. We used the USB 6008 or 6009 DACs. We're using different DACs. These are a little higher up, a little higher capabilities. These are it's the compact DAC. So this is the NI, National Instruments CDAC, compact DAC, and then 9174. And we have this chassis here. There are 2 cables. You'll need to unwrap these and plug them in. One of them is power. The previous ones we used, we didn't need power. It was just power over USB. Now we need to plug them in for power, and then they're still USB. We have USB out to our computer. This is how the data gets back and forth. For this to work, this is just the chassis. We need to have modules, and we can switch out different modules for different purposes. In this case, we're using thermocouples, so we want to use the NI9213. And this is a 16-channel 24-bit thermocouple input. This is meant specifically for thermocouples. It has a thermistor built in. That thermistor, it gives us the temperature of our reference junction, and it helps us to eliminate any error that would result from the additional thermocouple junctions that result from the wire connections between our thermocouple wires and the leads in here. So these just insert right into here, very simply. If you look, there's these little D-sub connectors. Just line them up down here. You'll have to pinch this, and it snaps in. Very easy. Little about this. To get this to work, you need to take a very small screwdriver. And Down the middle here, there are these more square openings. Here you want to insert, and it's important to get one of the small, like size 0 screwdrivers. You'll notice some of these, it's already getting damaged. So the plastic in the middle has become damaged. You should look at that and notice that, and if a channel looks damaged, then when you pick a channel in LabVIEW, do not pick that channel. But we have 16 channels here to pick from. Once you get good channels and you want to enter or insert your thermocouple wires, insert this little screwdriver into the square holes, push it in, and that will open up in the round holes a spot for you to insert your thermocouple wire. And once you've done that, then you just pull this out and the thermocouple wire will stay. There are quite a few important points here. The first two, so that they're numbered. We have 1 through 18 over here and 19 through 36 over here. 1 and 19, we don't want to put any thermocouples in there. But the rest of them are clearly labeled as TC0, so thermocouple channel 0, through TC15. Any of those that aren't damaged and that you select in LabVIEW, which we'll talk about in a separate video, any of those that you choose, you will want to insert your thermocouple wires into these. And you'll want to pay attention for several reasons to the colors of the thermocouple wires. We have a positive side and a negative side. You're going to want to make sure that you get the positive thermocouple wire and the negative thermocouple wire into the right side. It's a little counterintuitive. Most people do not think of red as the negative. It's not in most cases, but in thermocouples it is. So red will always go on the negative side, and the other color will go on the positive side. A little more about those colors. We have different specimens. They're either going to be white and red, purple and red, or blue and red. It's pretty straightforward with the white and red and the purple and red. Just look up a thermocouple table in your book, online, wherever, and find out what type of thermocouple it is. Special note about the blue one. So like I said, the white and the purple it's very straightforward. It's very obvious that they are those colors. The blue ones, it's kind of a transparent blue, and it's a copper wire underneath. And that copper has red in it. So you have red shining through a transparent blue, and it kind of looks a little purple. Students have definitely misinterpreted this to be the purple, which I think is type E. But it actually is blue, and it's the type T. Because of that confusion, the blue one has been labeled. I don't know if it'll actually be that way when you get here to do your lab, but just be aware of that. Don't mistake the blue thermocouples for purple. I think I've covered most of this. The one thing I'm not too certain that I've covered is once you get all this wired up, like I think I said, to make sure that you've tested it to make sure that it's working right. You don't want to put it in here, have it heat up, realize it's wrong, have to take it out and cool it down. You're not going to have time for that. So test everything, make sure everything's working fine, and once it is working fine, you want to take your specimen here, you want to open this up and just very quickly and smoothly, without dipping it in and taking it back out, insert it into the hot antifreeze. You don't want to have a bunch of noise at the start of your signal. So just do it smoothly and quickly and be done with it. I hope I've covered everything for equipment. I will end this video and I'll have another video for you regarding the VI program.